According to what we just said about the fundamental counting principle, the definition will be if an event occurs in n ways and another event occurs in n ways, then the total possible outcomes of these two events will be n times n or m times n ways. So this is an example of this that shows the definition of the fundamental counting principle. An event can occur 5 ways, which I got 5 tops over here. And another event or another set of outcomes occur in 5 ways, which is the bottoms that I've drawn. Then the total possible outcomes of both events to occur will be 5 times 5 ways, or m times n ways, and the result will be 25. A fundamental counting principle, the good thing about it is that it doesn't only work for 2 events. It can work for multiple events. So let's look at an example. If an event can occur in n ways, another event can occur in n ways, and another event can occur in b ways, and another event can occur in a ways, and so on. You just have to multiply them together. That's one great thing about fundamental counting principle. Sometimes a tree diagram will be too large. So, let's look at an example. If we have a special meal in a restaurant, and for the meal, you have to choose 1 beverage, 1 main entree, 1 side, and 1 dessert. So, for the beverage, I can choose soda, water, or juice. For the main entree, I can choose rice, noodles, and sandwich, and bread. For the sides, I can choose pineapple, soup, vegetables, roasters, or tater tots. And for the dessert, I can choose cake, pie, or ice cream. Now, if I use a tree diagram, if I want to find what is a possibility, how many possibilities are there? How many combination of meals can I choose from this meal set? So there are so many ways. If I use a tree diagram to match up the beverage with main entree and sides and dessert, will that work? Will that work? Can anyone answer my question now? Millie? Alright, so let's try to use a tree diagram here. So for the beverage, I can match soda with the main entree of rice. I can match these two together. And I can match rice with the pineapples and pineapples with cakes. So that means now that's one of the choices or one of the possibilities that I can choose for my meal. Well, and the soda can also match rice, and then the rice can match soup, and the soup can also match cake. If I keep doing this to water, juice, noodles, sandwich, bread, vegetables, roasters, tater tots, pie, ice cream, that would be a large tree diagram. And you don't want that, right? Yes! So, one way of counting these, rather than using a tree diagram, is to use a fundamental counting principle. The counting principle uses multiplication to find the number of possibilities of one or more events. So in here, I got 4 events: beverage, main entree, sides, and dessert. So how should we use a fundamental counting principle to count this? Yes. Rainy? Okay, so to use a fundamental counting principle, you have to multiply the number of outcomes together. Great. So you have to see there are 4 events. That means the event will come out with n times A times B. because there are 4 events, so I use 4 variables to substitute for them. For the n, I want it to be the first event, which is beverage. How many beverages I can choose from? 1, 2, 3. So that means for the event 1, I can have 3 possibilities. I can choose either soda, water, or juice. For the event n is my second event, main entree. For the main entree, I can choose rice, noodle, sandwich, and bread, which is a total of 4 events. For the A, which is the third event, sides, I can choose pineapple, soup, vegetables, roasters, or tater tots. That's a total of 5 events, so I multiply by that together. For the last event, B, which is for the dessert, I have 3 choices: cake, pie, or ice cream. So I multiply it by 3. So now I just have to solid multiply them. Simple, dimple, dimple. So 3 times 4 is 12, 3 times 4 is 12, 12 times 5 times 3. 12 times 5 is 60, and 60 times 3 is 180. So that's how you actually calculate and use the fundamental counting principle to count stuff, to count the number of possibilities an event can occur. So rather than using a tree diagram, let's try to use the fundamental counting principle. Good luck.
何か